So good day everyone. So for today's video, I will be discuss the continuation topic of the flood eroding, which is the attenuation. So attenuation. So from the figures 8.3 and 8.6, it shows the typical result of eroding a flood hydrograph through a reservoir. So owing to the storage effect, the peak of the outflow hydrograph will be smaller than that of the inflow hydrograph. So which means this reduction in the peak value is called attenuation. So katong peak sa the distance between the peak from the inflow and the distance and the peak of the outflow, that distance is what we call the attenuation, or it is the reduction value of the peak discharge from inflow hydrograph and to the outflow hydrograph. So further, the peak of the outflow occurs after the peak of the inflow. So it is stated that the time difference between the two peaks is known as lag, or it is what we call a lag time. Where it is the distance between two peaks of inflow and outflow hydrograph. The attenuation and lag of a flood hydrograph at a reservoir are two very important aspects of a reservoir operating under a flood control criterion. So take note na ang attenuation o ang lag is mo siya ang duha ka very important when it comes to reservoir operating under a flood control criterion. So by judicious management of the initial reservoir level at the time of arrival of a critical flood, so it is considerable attenuating of floods can be achieved. The storage capacity of the reservoir and the characteristics of spillways and other outlets controls the lag and attenuation of the inflow hydrograph. There are two figures as shown in the PowerPoint. So the first is figure, it is the variation of inflow and outflow discharge. So as you can see, naa siya duha ka graph or kaning hydrograph na which ang taas it is the inflow graph and the other one is the outflow hydrograph. So the peak between the inflow hydrograph and the outflow hydrograph is mao na siya ang gitawag natong attenuation. So on the other hand, the figure 8.6, it shows the result of the reservoir routing. Above the outflow and the inflow hydrograph, it shows the reservoir elevation. So I have here some sample figure to identify the attenuation, the inflow hydrograph, and the outflow graph. So as you can see in the sample figure 1, it shows the tow curve, which is the inflow hydrograph and the outflow hydrograph. And as you can see, the peak of the outflow to the peak of the inflow is what we call the attenuation. Then the distance between the intersection between the inflow and the outflow hydrograph to the peak inflow is mo na gitawag nato na lag time. So as you can see, the red na kanang mga broken line mo na siyang nagkuan as lag time. In sample 3, as you can see, there are green colors which signifies, or it shows that this part is the storage area of the inflow, and on the lower part is the storage area of the outflow. So again, in the figure 8.3 and 8.6, in the rising part of the outflow curve, where the inflow curve is higher than the outflow curve. So makita man natin dito nakatong ang inflow curve is mas taas pa siya kaysa sa outflow curve. So the area between two curves indicate the accumulation of the flow of the storage. Kung atong area between sa the inflow curve and the outflow curve is mo to siya ang gitawag nato na flow of storage. So in the following part of the outflow curve, the outflow curve is higher than the inflow curve, and the area between two indicate depletion from the storage. So in the following part of the outflow curve daw, ang outflow curve is higher na siya kaysa sa inflow curve. When the outflow from the storage reservoir is uncontrolled, as in a freely operating spillway, so ang peak of the outflow hydrograph will occur at the point of intersection of the inflow and outflow curves as shown in the figure 8.3 and 8.6 as proof in example 8.3. So the example 8.3, it showed that in the level pole, routing of the peak of the outflow hydrograph must intersect the inflow hydrograph. So here's the solution in getting the formula of the accumulation or the depletion of the attenuation. So as you can see, S is equals to a function of water surface elevation in the reservoir, or it is equals to H S times H. So derivative of S over derivative of T is equals to A dH over T. So ang DS is mo ni siyang gitawag nato na change in storage din ang sa time dayon. So where A is equals to the area of the reservoir at elevation H, then ang outflow or gikuan lang nato siya unit as Q is the function of H, or it is equals to Q function of H. So at peak outflow, so sa peak sa outflow, dQ or the D outflow over the dt is equals to 0. Hence, ang ds over dt is equals to 0. So also, when dH over dt is equals to 0, ang ds over dt po nato is equals to 0. So by continuity equation, I minus Q over ds over dt. So ang I, mauna siya ang ato ang inflow, then i-minus nato siya sa Q, which is the outflow. Is equals to change in storage and the time dayon. So when ds over dt is equals to 0, so ang I is equals to Q. So hence, when the peak outflow occurs, so ang I is equals to Q. And thus, the peak of the outflow hydrograph must intersect to the inflow hydrograph as shown in the figure 8.3 and 8.6. So it is really important na katong ang peak sa outflow hydrograph is dapat naka-intersect siya sa inflow hydrograph. Katong nakita na ako na sample figure na nag-intersect sila katong ang curve sa inflow kaning curve sa outflow. So I guess that's all for my report. Thank you.